Thanks, Jan. One moment. Okay, yes, I am here to introduce the fisheries topic. And as Jan mentioned, the NANOOS fisheries community is large. It includes things like rockfish and groundfish and salmon and shellfish and Dungeness crab and salmon and tuna. And so and that's not all of them, right? This category is meant to be inclusive and for you to see yourself in it as you can. And our use case today, what I'm going to do is give you a little bit of history, just as an example, on our Tuna Fishers app. But again, it's just one example. So, and this was great also for me to learn as a new NANOOS employee. So back in 2008, there was a tuna fisher out of Oregon in Coos Bay who had been kind of independently exploring the Oregon State University's ROMS sea surface temperature model output. And one day couldn't access it. And so he reached out to the scientist that was in charge of it, Alex Kurapov. And Alex then connected with NANOOS and said, you know, this tuna fisher has been using this information from my model. Maybe we should kind of go forth and make something more useful with this. And so NANOOS worked with the fisher. And the biggest feedback was that, you know, it'd be great to be able to see the sea surface temperature data along with currents. And the temperature really, we don't need all the temperatures. We find that tuna typically are between 58 and 62 degrees Fahrenheit water. That's their sweet spot. And let's hone in on that. And like you see on the figure here, let's color it with something that's more intuitive to us and kind of highlighting the places where we think tuna might show up. So we changed from a rainbow to a red, white, blue. And then in 2009, there was another fisher who reached out and said, you know, very seldom have we ever caught tuna at chlorophyll content greater than 1, right? Normally we're seeing, you know, in the temperature of water that they like, we're normally seeing them between 0.4 and 0.6 in chlorophyll. And so we added to the development of this Tuna Fishers app a layer from a MODIS satellite, a color product that gives you kind of a chlorophyll stand-in. And again, tuned the range of what you could see to the range that was applicable for tuna. And in 2013, in March 2013, we officially launched the Tuna Fishers app after a lot of user testing. And in 2021, this past year, the Tuna Fishers app reported over 41,000 individual page views. It is our most used app, and there's always a surge during the fishing season. But it's been a really successful app. And I think that this highlights the importance of engagement with you all, and that you should feel free at any time to reach out to us and let us know what's working or what's not, or what you wish we had, because this is an example of kind of an organic formulation of a tool that has turned out to be really useful to the larger community. So I think it just is a great example of the flavor of what we're trying to do today as well. Now, to give you a better understanding of how maybe all of NVS, some of the different apps and the Tuna Fishers app is used in supporting fishing, I'm going to turn the floor over to Oregon fisher Mark McCulloch. Thank you so much for being with us today, Mark. Take it away.
Welcome, Roxanne. Thank you for the introduction. Good morning, everyone. So early on, you mentioned that this started as a Tuna Fishers app, but it ends up being useful for a lot more than just tuna. So I wanted to throw that in there. Go ahead and go to the next slide, please. So the pieces that I'm going to summarize here are the base maps, what starting maps we use, what charts, surface temperature, chlorophyll, which you've mentioned both of those, but also surface currents, and then the model that does future predictions of both current and temperatures, and then the routing function. And just as an example of some of the other fisheries, this has helped me personally on the picture there with me with some canary rockfish, which I'll touch on that in a minute. Next slide. So for the base maps, on the left side of the screen when you log in, you'll see all the different layers that are available. And with the boxes if you check on the NOAA nautical chart, that's the the old-fashioned NOAA chart. So the paper charts that we've used for years. Although there's been a a change in the base map, it doesn't look quite the same as it did. And I think the change was probably within the last year or year and a half. And I'd be curious to talk about that in the breakout section. But it has a zoom function, so right now that view doesn't actually show depth contours, but if you zoom in, it shows depth contours. So again, that's the basic NOAA map and NOAA chart. And you'll notice at the top, it shows the latitude and longitude of wherever your cursor is. And there's also a settings tab that we use to change from degree decimal to the format that you see, which is the more common format. Now, if we were to change the base map, so next slide, please. You'll notice on the left side, I've also checked bathymetry contours. So it starts to look a little bit busy, but now you have these bathymetry map contours overlaid on top of the NOAA chart. And what's interesting about this is that it often shows different shapes, because again, the NOAA data is pretty old. The soundings often are not that close together, so the lines are more of an average, whereas these bathymetry contours can be more detailed. So this is really helpful for locating bottom fishing areas, halibut fishing areas, and as we get further offshore, those contours can also indicate where local upwellings will be. And as we always say in science, watch your units, because the bathymetry contours are in fathoms, but the NOAA nautical charts are now in meters. So in a little inset there, there's some detail on top of Stonewall Bank, and it kind of shows an example where the soundings are actually in different values. So something to pay attention to. Next slide, please. On your cover sheet, you actually, I stole that image of the temperature view in red, because the current view, the image on the right side of the screen where it's mostly purple, you can see on the scale below, this time of year the water's a lot colder. So on the menu on the left sidebar, there are actually different temperature data fields, and so this one looks different than the one on the cover sheet. But again, on the right hand side, you can kind of see that the temperature data is overlaid on top of the bathymetric data. So again, that's really helpful to be able to see what's happening with with temperature as well as chlorophyll in relation to the bottom structure, because as you know, they relate to each other as far as currents and upwelling, when they hit ledges or coastal features. So there's a definite relationship there, and that helps us in many fisheries. I mentioned there on the notes on the left side for tuna, which again, the original application, we often look for temperature breaks. So again, if you look at the red image, you can see in the bottom of the image, there's an area where the solid red has a kind of a sharp color edge against the white part. So that's what we would call a sharp temperature break, versus at the very top of the image off of Juan de Fuca, you can see sort of those in between pink colors. So what we would see there is a very gradual raise in temperature as you're moving across the ocean. But for tuna, we're often looking for those very sharp temp breaks, because that's where you're going to find most life. And it also correlates with the color change with the chlorophyll. What's also important are these arrows showing the direction of the current. You'll notice again in that image on the left, arrows going every which direction, but in the middle it shows some arrows that are more in bold, so that's a higher velocity, and it also shows the direction. And when we start to see these arrows, kind of going in circles, you can see it's almost like whirlpools where they spin and can collide with each other. We call that a current convergence. And so when we don't have temperature data because of cloud cover, those current lines can often be helpful to decide where to fish for tuna. Next slide, please. So this is an example now of the chlorophyll image. So as you mentioned earlier, the ranges, the ideal ranges of 0.1 or 0.4, et cetera. So this is also going to correlate with water color. So typically what we see is closer to shore, you have colder water, and that's where the most upwelling typically occurs. And so in this example, it's more dense, closer to shore, the more orange and red colors. But we also can see some of these upwelling plumes, off the coast, and those will often occur again in conjunction with seamounts, Stonewall banks, Heceta banks, and it also aligns with those current arrows. So in the summer, the prevailing current in this area is from north to south, but we'll see those current arrows literally turn towards the west, and that'll often be associated with these chlorophyll plumes that will shoot offshore. So again, we're using that both to find salmon, because salmon are typically found in the more dense chlorophyll areas that's associated with more feed. But we're trying to stay away from that, for tuna. So it's sort of the opposite. For tuna, we're looking for where the clear water comes up against the chlorophyll water. But for salmon, it's sort of the opposite. We're trying to stay inside of the clear water. And again, we're using this in conjunction with the temperature charts. And by the way, on the left side, you can see that with the options for chlorophyll, there are different time frames. And so it depends on what's happening with the cloud cover. If we get numerous days of clear weather, then we can use the one-day shot that shows the most current real time. But when we have cloud cover or partial cloud cover, then we'll tend to use the composites, the 3-day average or even the 8-day average. Next slide, please. So here's an example of the current direction and speed. And again, on the left side menu, I've chosen one that's a 25-hour, and so this is off of Central Oregon coast. You can kind of see Newport, Seal Rock, and Wallport there, and then in the middle is Stonewall Bank. So you can see these arrows going generally from north to south, but then in certain areas they kind of bend towards the west. And it just so happens that's also where there's higher velocity and different structures. So out at Stonewall Bank, you can see green, slightly higher velocity right on top of it. So it's just like a river when you have boulders or features that cause the water to move different directions. We kind of see the same thing going both down the coast and offshore on these seamounts. It's actually my understanding that the commercial crab fishers use this data to decide which way to lay their gear, if they haven't been out for some number of days. So there's lots of different applications of this current data. And again, I mentioned when there's cloud cover, and you all could speak to this better than I can, but the technology used for current does not rely on clear skies. And so if we haven't had good satellite image for days and days, we can use this to kind of predict where the dirty water might be or might not be. Or if we knew that it was at one point north and south, we can make some assumptions about where it may have moved to. So this current data is very valuable. Next slide, please. And this shot here, if you look at the top of the image, we move from map to plots. And I think this came from the original, was it called Orcus? And it's when I first met Craig Rissian. And this is particularly helpful because it uses a model for future predictions. And so again, I keep mentioning cloud cover because when it comes to fishing on the ocean, especially in a small boat, you want calm weather, but more often not, when it's calm, when there's no wind, it also means that it's foggy or overcast. When it's really windy and rough, that's when the skies are clear. So you get a good image when you can't go fishing. But in this case, their computer model can take all the existing data, predictions about which way that the pressure systems are moving, and all those forecasting tools, and actually predict future surface temperature and current data, surface current data. And so this one is particularly helpful for, again, we can often go for 7 or 10 days without a clear satellite image, but yet this data will still be there and predict what's going to happen with the currents and the temperatures in 24 or 48 hours. In fact, I'm kind of surprised more people don't use this one because, again, you can hear people just griping for days on end in the summertime or in the fall about no good satellite images. I believe that's the last of my slides. Oh no, excuse me, there's the routing slide. So when we're planning a trip, both in terms of trying to find new areas to fish and deciding where to go, there's this route function. And in this particular example, I started out at the jetty of Newport and went to the north end of Stonewall Bank. And so the idea here is, we're planning a trip. Let's go to the north end of Stonewall Bank, and then let's plan on going to the south end of Stonewall Bank, and then back in. You can't see it on the larger image to the right because when you hover your cursor over the line, and you can kind of see it on the left side, there's a little pop-up that will tell you the distance. So I know it's kind of blurry, but that little white square on the left side image will tell you the distance of that leg of the route, and it will tell you the course. So this will allow us to, again, add up the distances of our planned trip, which is important for fuel considerations. Fuel management is really important, especially with tuna fishing when you're going 30 or 40 or 50 miles offshore. So when we're looking at things like that temperature data, and we find a temperature break we're interested in, then we can map out how far it is to that temperature break and decide if it's worth it to go that far. Now, I think that is the last slide. I'll take any questions, and that's my email address if anybody would like to send me a note. Thank you.